Welcome back to The Explainer. I'm absolutely thrilled to be with you today, especially all of you tuning in from the PyLadies Rivers community. We are setting the stage for something monumental right now, Week 5, Part 3B of your Python Programming for Beginners journey. We're going to master Python functions, look at exactly where things usually go wrong, and learn how to write code like true professionals. Let's get right into it.
First off, a massive congratulations to you. Reaching Week 5, Part 3B is a huge milestone. Seriously. Why? Well, because this is the exact moment we bridge the gap between just knowing basic Python syntax and actually writing professional, reusable code. You're officially moving from being a beginner who writes scripts to a developer who engineers solutions.
Now, as we level up, I really want you to keep this mindset. Making mistakes is a mandatory part of learning. I mean it. I want to frame errors not as failures, but as, well, expected little monsters on your hero's journey of coding. Even the most experienced developers see red error text every single day. It is totally normal, and today we're going to learn how to defeat those monsters.
So here's our roadmap for this explainer. We'll start with a Week 5 wrap-up, then tackle common beginner mistakes, go over essential tips for debugging, dive into pro developer best practices, and finally look at real-world practice projects.
Section 1. Week 5 Wrap-Up. Let's kick things off with a really quick recap of the foundational concepts you've successfully conquered so far.
So, you've learned what functions are and why they matter. They're basically the building blocks of reusable code. You know the mechanics of creating and calling them, how parameters receive information while arguments supply it, and you've tackled the whole concept of scope, local versus global variables dictated by the LGB rule, meaning local, enclosing, global, and built-in scopes. This foundation is rock solid, and now it's time to pressure test it.
Section 2. Common Python Beginner Mistakes. This brings us to our first set of challenges. Remember, seeing an error pop up is literally just Python trying to talk to you. Let's see what it's saying.
Okay, let's dive right in. Say you have a perfectly written function, but when you run the program, absolutely nothing happens. Why is that? Well, because simply creating a function doesn't execute it. It's kind of like writing a recipe, but never actually cooking the meal. To see the output, you have to explicitly call the function by typing its name followed by parentheses, like greet, to actually tell Python, hey, run this code now.
You also have to remember how strict Python's structure is. A missing colon or a lack of indentation will instantly result in a syntax error. No way around it. Python relies heavily on that colon at the end of the def statement and the indentation right underneath it to know exactly what code belongs inside the function. Give it that perfect harmony of correct syntax, and it'll run beautifully.
Now, what happens when we introduce arguments? Let's say a function expects two pieces of information, like A and B. If you only pass one, Python is going to throw a type error. But the cool thing is, it'll explicitly tell you that it expected two arguments but only received one. You just have to give Python exactly what it asks for, and it works perfectly.
Then there's a classic scoping issue. Imagine a variable called message is created inside a function, but when we try to print it outside that function, we get a name error. Why? It's all about scope. What happens inside a function stays inside a function. Local variables simply do not exist out in the global space.
And this brilliantly illustrates one of the most common beginner slip-ups, forgetting to return data. A function might do all the math perfectly, but without a return statement, the output is simply none. It essentially keeps the calculation a secret. By using the return keyword, the function successfully hands the value back to the main program so you can actually use it.
Section 3. Essential tips for debugging. Now that we've faced the monsters, it's time to shift our narrative and equip you with your primary weapons.
First off, let's normalize this term. Debugging is simply the process of finding and fixing errors in your program. And I want you to know that professional programmers spend a massive amount of their day doing exactly this. You aren't failing when you debug, you are doing the job of a developer. So welcome to the club.
Here is your professional workflow. Step 1. Read the error message carefully. Python is literally trying to help you by telling you the exact file, the line number, and the type of error. Always start there. Step 2. Don't write 100 lines of code at once. Test small pieces, maybe 10 lines at a time. Step 3. Use the print function to check the values of your variables mid-program to see what's actually happening. And Step 4. Keep your functions small. Smaller functions are just infinitely easier to test and fix.
Section 4. Pro Developer Best Practices. All right, let's transition from fixing errors to avoiding them altogether. Let's talk about those Jedi mindsets that'll help you write clean, maintainable code right from the start.
Rule number 1 is all about descriptive names. If you name a function ABC, literally nobody knows what it does. But name it calculate_total, and instantly its purpose is obvious. Meaningful names make programs infinitely easier for humans to read and understand. Because remember, you write code for machines to execute, sure, but you write it for humans to read.
Here are your core pro habits. First, one function, one responsibility. Don't build a massive function that tries to do everything. Break tasks down. Have one function calculate tax and a totally different one print the receipt. Next, avoid repeating code. If you find yourself copying and pasting code, it should probably be a function. Always try to use parameters to pass information into a function rather than relying on global variables. And, like we saw earlier, return values so your functions are actually reusable.
Code organization is absolutely paramount. Simply adding a clear comment above your function, like calculate employee salary, and grouping related functions together near the top of your program drastically improves how your code reads. It's kind of like adding street signs to a city map. It just makes navigating the whole thing so much easier.
Section 5. Real-world practice projects. Okay, it's time to take everything we've talked about and head straight to the training ground. Let's look at the real-world practice projects where you'll apply these concepts.
You have a fantastic set of exercises lined up. You'll be building practical tools, functions that calculate the area of a rectangle, functions that check if a student passes or fails based on a score threshold, and functions that tally up grocery costs. These aren't just abstract math problems, guys. These are the actual building blocks of real working software applications.
And for your main assignment, you're going to build 4 incredible mini applications: a calculator, a student report card system, a bank account simulator handling deposits and withdrawals, and a shopping receipt generator calculating VAT. I want you to feel really proud of this. For each of these, you'll use separate, small, distinct functions to handle specific operations. This is where you really become a true developer. Key takeaways and next steps. As we begin to wrap up this explainer, I really want to connect these foundational lessons directly to your future as a software engineer. So the crucial point is this. Functions are the absolute foundation of professional software development. They eliminate repetitive code, you know how parameters and arguments communicate, you understand that scope dictates where variables live, and you know that small, reusable functions are the secret to software that is actually maintainable. Almost every major Python application out there, from cutting-edge AI systems to massive web development backends, relies on these exact principles.
I want to leave you with a habit-forming question. I want you to ask yourself this every single time you sit down to code from now on. If I'm writing the same code more than once, can I turn this into a function? Take that provocative thought with you into your assignments and let it guide you as we prepare to explore Python modules and libraries in week 6. Keep practicing, keep making those mistakes, and keep learning. Thank you for joining me on The Explainer, and happy coding!